Hey beautiful minds, welcome to Gen Z Learning. Today we will be learning the chapter Motion in a Plane. So let's begin. Let's look into scalar and vector quantities. Scalar quantities are defined as the quantities which have only magnitude and no direction. For example, mass, distance, time, speed and work. Whereas vector quantities are defined as the quantities which have both magnitude and direction and obey the triangle law of vector addition or equivalently the parallelogram law of vector addition. For example, position, displacement, velocity and force. These two laws will be learned shortly. Let's look into general vectors and their notations. A vector can be represented by an arrow. This part of the arrow is known as arrowhead, which represents the direction, whereas this part is known as tail, which represents the magnitude. If the magnitude of a vector quantity is A, then vector can be written as capital A on top of which there is an arrow. Next we have position and displacement vectors. Position vector is a vector drawn from origin to a point. For example, from origin to a point say P with distance r1 vector. Same thing goes here from origin to a point say Q with distance r2 vector. Displacement vector is a vector drawn from one point to another. It is the difference between the final and the initial position vector. That means PQ vector is equal to OQ vector minus OP vector, which basically means PQ vector is equal to R2 vector minus R1 vector. Let's move on to zero vector or null vector and its properties. If two vectors A and B are equal, then their difference is A vector minus B vector is defined as zero vector or null vector and is denoted as 0 on top of which there is an arrow. Mathematically, A vector minus B vector is equal to 0 vector if A vector is equal to B vector. Thus, the zero vector is a vector of zero magnitude having no specific direction. Properties of zero vector. First one, the sum of a finite vector A and the zero vector is equal to finite vector. That is, A vector plus zero vector is equal to A vector. Second one, the multiplication of a zero vector by a finite number n is equal to the zero vector. That is, n into 0 vector is equal to 0 vector. Third one, the multiplication of a finite vector A by 0 is equal to 0 vector. That is, 0 into vector A is equal to 0 vector. Next topic is equality of vectors. Two or more vectors are said to be equal if and only if they have same magnitude and same direction. For example, here A vector, B vector and C vector all three have same magnitude and same direction. But in case of D vector, the magnitude is same but the direction is reversed. So, since D is in a reverse direction, the sign also gets reversed and thus we get A vector equal to B vector equal to C vector equal to minus D vector. The next topic is addition and subtraction of vectors. Suppose there are two vectors A vector and B vector. Now we draw a resultant vector R vector from A vector to B vector. Now how do we know whether we should add or subtract? For addition, R vector's tail should be attached to the tail of the other vector. In the same way, R vector's arrowhead should be attached to the arrowhead of the other vector. So in the first case, we get addition. So R vector is equal to A vector because it starts from A vector plus B vector because it goes on till B vector. Now in the next case, let's draw the resultant vector from B to A. In this we can see the tail of the R vector is attached to the arrowhead of the B vector, which is minus, and over here the arrowhead of the R vector is attached to the arrowhead of the A vector, which is plus. Here there is a slight change. R vector will be preferring A vector first because A vector hits the same arrow vibe like R vector, whereas the B vector doesn't hit the same vibe as the R vector. So even though R vector started from B vector, R vector will be equal to A vector minus B vector. Now let's look into the third case. In this we will be drawing resultant vector from A vector to B vector. In this case, A vector is not hitting of the same tail vibe like the R vector, so it will be considered as minus and also in the second place, whereas B vector is hitting of the same arrow vibe with the R vector, so minus B vector will be considered as plus, and in the first place we get R vector is equal to B vector minus A vector. Next topic is unit vector. A vector whose magnitude is unity is called a unit vector. So the formula goes like A cap is equal to A vector by A, where cap is used to represent unit vector and A vector is vector. Here A is magnitude. What are orthogonal unit vectors? The unit vectors along the x-axis, y-axis and z-axis are called orthogonal unit vectors. They are written as I cap, j cap and k cap. The next topic is resolution of a vector. The resolution of a vector is opposite to vector addition. If a vector is resolved into two vectors whose combined effect is the same as that of the given vector, then the resolved vectors are called the components of the given vector. Now let us look into the diagram. We know that theta on x-axis is cos theta and theta on y-axis is sin theta. Resolving the vector on x-axis we get a cos theta. Now resolving the vector on y-axis we get a sin theta. With the help of these components we can calculate the magnitude and direction of the vector. For magnitude, A is equal to root of square of sum of its components ax and ay. For direction, tan theta is equal to ay by ax. Why ay by ax? Because tan theta is equal to sin theta by cos theta. Then we get theta is equal to tan minus 1 into ay by ax. The next topic is scalar product or dot product of two vectors. The scalar product of two vectors is defined as a scalar quantity equal to the product of their magnitudes and the cosine of the angle between them, which is mathematically A vector dot B vector is equal to AB cos theta. For example, W work is equal to F vector dot S vector. Properties of scalar product. First property. The scalar product is commutative. That is A vector dot B vector is equal to B vector dot A vector. Second property. The scalar product is distributive. That is A vector dot B vector plus C vector is equal to A vector dot B vector plus A vector dot C vector. Third property, the scalar product of two mutually perpendicular vectors is 0. That is, A vector dot B vector is equal to AB cos 90, which is equal to 0 because cos 90 is 1. Fourth property, the scalar product of two parallel vectors is equal to the product of their magnitudes, which means A vector dot B vector is equal to AB cos 0, which is equal to AB because cos 0 is 1. Fifth property, the scalar product of a vector with itself is equal to the square of the magnitude of the vector, which means A vector dot A vector is equal to A into cos 0, which is equal to A square because cos 0 is 1. Sixth property, the scalar product of unit orthogonal vectors I cap, j cap, k cap have the following relations. I cap dot j cap equal to j cap dot k cap equal to k cap dot I cap is equal to 0 because multiplication of different unit orthogonal vectors will give us 0, whereas I cap dot I cap equal to j cap equal to k cap is equal to 1 because multiplication of same unit orthogonal vectors will give us 1. Seventh property. The scalar product of two vectors is equal to the sum of the products of the corresponding xyz components, that is A vector dot B vector is equal to ax bx plus ay by plus az bz. Next topic is vector product or cross product of two vectors. The vector product of two vectors is defined as a vector having a magnitude equal to the product of the magnitudes of the two vectors and the sine of the angle between them, and having the direction perpendicular to the plane containing the two vectors, which is mathematically A vector cross B vector equal to AB sine theta. This is the angle A vector B vector into n. For example, T vector equal to R vector cross F vector, where T here is torque. Properties of vector product. First one, the vector product is not commutative, that is A vector cross B vector is not equal to B vector cross A vector. Second property, the vector product is distributive, that is A vector cross B vector plus C vector is equal to A vector cross B vector plus A vector cross C vector. Third property, the magnitude of the vector product of two vectors mutually at right angles is equal to the product of the magnitudes of the vectors. We know that A vector B vector here is an angle. So A vector cross B vector is equal to AB sine 90 n cap, which will give us AB n cap cos sine 90 is 1. Fourth property, the vector product of two parallel vectors is a null vector or 0, which means A vector cross B vector is equal to AB sine 0 n cap, which will give us 0 vector or 0. Fifth property, the vector product of a vector by itself is a null vector or 0. That is, A vector cross A vector is equal to 0. Sixth property, the vector product of unit orthogonal vectors I cap, j cap, k cap have the following relations. I cap cross j cap or minus j cap cross I cap is equal to k cap. J cap cross k cap or minus k cap cross j cap is equal to I cap. K cap cross I cap or minus I cap cross k cap is equal to j cap. Therefore, multiplication of two unit orthogonal vectors will give us the third one. Next one, I cap cross I cap equal to j cap cross j cap equal to k cap cross k cap will give us 0. Therefore, multiplication of same unit orthogonal vectors will give us 0. Seventh property, the vector product of two vectors in the terms of their xyz components can be expressed as a determinant. Next topic is relative velocity. First point, VAB vector is equal to velocity of A with respect to B. That is VAG vector minus VBG vector. G here is nothing but ground. Second point, VBA vector is equal to velocity of B with respect to A. That is VBG vector minus VAG vector. Third point, velocities will be subtracted when going in same direction. Fourth point, velocities will be added when going in opposite direction. Just know the basics. We will be starting with numericals shortly. Next topic is geometrical interpretation of vector product. Suppose two vectors are represented by sides OP and OQ of parallelogram OPQR, B vector and A vector. Theta is the angle between vector A and vector B. Draw QN perpendicular to OP. From triangle ONQ, we know that QN is equal to B sin theta. How do we get B sin theta? Let me explain. A triangle is drawn here from the parallelogram with base, perpendicular and hypotenuse. We know that P by H is equal to sin theta. Know that H here is B. So we get B sin theta. First step, A vector cross B vector is equal to AB sin theta n cap. We replace n cap by using mods here. A vector cross B vector mod is equal to A here is OP. B sin theta is QN. OP into QN is the area of parallelogram, base into height. Second step, A vector cross B vector mod is equal to OP into QN. Next we do 2 by 2 into OP into QN and get 2 into half into OP into QN, which is the area of the triangle. Then the final step is 2 into area of OPQ. The next topic is analytic method of vector addition. First one, triangle law of vector addition. This law states that if two vectors are represented in magnitude and direction by the two sides of a triangle taken in the same order, then their resultant is represented by the third side of the triangle taken in the opposite order. Now let us derive the resultant. OQ square is equal to QE square plus OE square, where OQ square is R square, equal to QE square. We still have to find QE. Resolving the B vector on x-axis, we get B cos theta. Resolving on y-axis, we get B sin theta. Now QE whole square is B sin theta whole square, plus OE whole square is A plus B cos theta whole square. R square is equal to B sin theta whole square will give us B square sin square theta, plus A plus B cos theta whole square. Using A plus B whole square formula, we get A square plus B square cos square theta plus 2AB cos theta. Now we take A square and B square common and get A square plus B square sin square theta plus cos square theta plus 2AB cos theta, where sin square theta plus cos square theta is 1. We get R square is equal to A square plus B square plus 2AB cos theta. Then we remove the LHS square and root the RHS. We get R is equal to root A square plus B square plus 2AB cos theta, the resultant. Next we need to find the direction. So tan alpha is equal to y by x, where y is b sin theta and x is a plus b cos theta, and get tan alpha is equal to b sin theta by a plus b cos theta. This is how we derive the direction of the resultant. Second one, parallelogram law of vector addition. This law states that if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. Resultant R is equal to root of a square plus b square plus 2ab cos theta, and direction tan A is equal to B sin theta by A plus B cos theta, the same as the triangle law of vector addition. Special cases. First one, when two vectors are in the same direction, then theta will be 0, so cos 0 will be 1 and sin 0 will be 0. Using equation 1, root a square plus b square plus 2ab cos theta. Cos theta is 1, so it gets multiplied with 2ab and we get R is equal to root a square plus b square plus 2ab. This is the formula a plus b whole square. Now we remove the roots, so the square also cancel out and we get a plus b. This is the resultant. For direction, using equation 2, b into sin theta is 0, so b into 0 by a plus b cos theta is 1, so a plus b. We get tan A is equal to b into 0 by a plus b, which gets multiplied to become 0. Second case, when two vectors are at right angle to each other, then cos 90 is 0 and sin 90 is 1. Using equation 1, we get R is equal to root a square plus b square plus 2ab cos 90. Since cos 90 is 0, it gets multiplied with 2ab, which also becomes 0. We get R is equal to root a square plus b square. Now removing the roots and cancelling the squares, we get R is equal to a plus b. This is the resultant. Now we will also find the direction using equation 2. We get tan A is equal to b sin 90 by a plus b cos 90. Since sin 90 is 1 and cos 90 is 0, we get tan A is equal to b by a. This is the direction. Third case, when two vectors are in opposite directions, then cos 180 is equal to minus 1 and sin 180 is equal to 0. Using equation 1, we get R is equal to root of a square plus b square plus 2ab cos 180. Since cos 180 is minus 1, we get R is equal to root of a square plus b square minus 2ab. Since it is in this format, we get R is equal to root of a minus b whole square. Removing the root and cancelling the square, we get R is equal to a minus b. This is the resultant. Now we calculate the direction using equation 2. We get tan A is equal to b sin 180 by a plus b cos 180. Since sin 180 is 0 and cos 180 is minus 1, we get tan A is equal to b into 0 by a minus b, which gives us 0. This is the direction. Let's move on to the last topic of the chapter, the questions. First question, find the unit vector parallel to the resultant of the vectors. A vector is equal to 2i cap minus 6j cap minus 3k cap and B vector is equal to 4i cap plus 3j cap minus k cap. Take C as the resultant vector. The formula for unit vector is C cap is equal to C vector by C. So to find C vector, we need to add A vector plus B vector. 2i cap plus 4i cap is 6i cap. Minus 6j cap plus 3j cap is minus 3j cap. Minus 3k cap minus k cap is minus 4k cap. We found C vector. Now we have to find the magnitude of C. To find the magnitude of C, we do the square of root of sum of its components. We get C is equal to root of 6 square plus minus 3 square plus minus 4 square. Working this out, we get root of 36 plus 9 plus 16, which is root of 61. Now we put the C vector and C magnitude values here and we get C cap is equal to 6i cap minus 3j cap minus 4k cap by root 61. Now we separate the xyz components and get C cap is equal to 6i cap by root 61 minus 3j cap by root 61 minus 4k cap by root 61. This is the answer. Second question. A boatman can row with a speed of 10 km h-1 in still water. If the river flows steadily at 5 km h-1, in which direction should the boatman row in order to reach a point on the other bank directly opposite to the point where he started? The width of the river is 2 km. Velocity of boat VB is 10 km h-1. Velocity of river VR is 5 km h-1. This is the river, this is the width of the river, this is the speed of the river 5 km h-1. This is the boat with a speed of 10 km h-1. Theta here is the angle between VR and VB. For the boat to travel from here to here, in which direction should the boatman row? We know OC hypotenuse, which is 10 km h-1. We know AC perpendicular, which is 5 km h-1. But we don't know OA, which is the base. So we make use of sin theta. Sin theta is perpendicular by hypotenuse. Perpendicular is 5 km h-1. Hypotenuse is 10 km h-1. We get 5 by 10, which is 1 by 2. So theta will be equal to sin minus 1 by 2. So the theta will be 30 degrees. The required angle is 30 degrees for the boatman to row in order to reach a point on the other bank directly opposite to the point from where he started. Third question. A vector is equal to 3i cap plus 4j cap and B vector is equal to 12i cap minus 5j cap. Determine A. Magnitude of A vector, B. Value of A vector dot B vector. To determine the magnitude of A vector, we do the sum of root of square of its components and get root of 3 square plus 4 square which gives us root of 25. Root of 25 is 5. Next we have to find the value of a vector dot b vector. We get 3 I cap plus 4 j cap dot 12 I cap minus 5 j cap. On multiplying we get 36 I cap minus 20 j cap. On removing unit orthogonal vectors we get 16. The value of a vector dot b vector. Fourth question. Find the scalar and vector products of two vectors. A vector is equal to 3 I cap minus 4 j cap plus 5 k cap and B vector is equal to minus 2 I cap minus j cap minus 3 k cap. To find the scalar product A vector dot B vector we get 3 I cap into minus 2 I cap we get minus 6 I cap. Minus 4 j cap into minus j cap will give us plus 4 j cap. Plus 5 k cap into minus 3 k cap will give us minus 15 k cap. On removing unit orthogonal vectors we get minus 17, the scalar product. For vector product, A vector cross B vector is equal to I cap, j cap, k cap. In these places, we will be putting these values. I cap first is plus 3, j cap is minus 4, k cap is plus 5. Then in B vector, minus 2 I cap, so minus 2, then minus 1 j cap, then minus 3 k cap. In the next step, we arrange I cap, j cap and k cap separately. Also remember, in the second step, j cap should be always minus. In I cap space, we will be filling the value of j cap and k cap and ignoring I cap. Same goes to minus j cap, except j cap, we will be filling the values of I cap and k cap. And get, same goes to k cap, except k cap, we will be filling the values for I cap and j cap. And get, next we write I cap, multiply these two and these two. We get minus 4 into minus 3 plus 12 minus plus 5 into minus 1 is minus 5. Then minus j cap. We multiply this. 3 into minus 3 is minus 9 minus 5 into minus 2 minus 10. Then plus k cap. We multiply this and this and this and this. Plus 3 into minus 1 is minus 3 minus 4 into minus 2 is plus 8. I cap 12 minus into minus is plus. So 12 plus 5 is 17. So 17 I cap, then minus j, minus 9, minus into minus is plus 10. So minus 9 plus 10 is 1. Plus k, don't forget to put the caps. Minus 3 into minus 8, no sorry, I mean minus 3 minus 8 is minus 11. Then we get 17 I cap minus j cap minus 11 k cap. This is the answer. Sixth question and the last question. A car A moving at 10 ms minus 1 on a straight road is ahead of another car B moving in the same direction at 6.0 ms minus 1. Find the velocity of A relative to B and vice versa. First one, velocity of A relative to B. That is VAB is equal to VA minus VB. With VA being 10 ms minus 1 and VB being 6.0 ms minus 1, we get 10 minus 6.0 equal to 4.0 ms minus 1. B sees car A pulling away at this rate. Let's look into the second part. Velocity of B relative to A. That is VBA is equal to VB minus VA. Putting the values we get 0.6 minus 10, Subtracting this, we get minus 4.0 ms minus 1. A sees car B dropped behind at this rate. Thank you for watching. Hope you enjoyed the video. Hit the subscribe button for more such videos.